Yeah. Okay, it is better.
Come at least one bench. Your mobile sounds switched off.
Silent, but
I think you came back to the same.
I'm telling you that my sister.
No, I know you told me. I also suggested that you get
No, actually, I was thinking I'll write it all, then I skip this one. But that ruling sleep will be like a
Okay, last time I think we have done this one. What is the formula for Ohm's law? Keep your books open. Next book, notebook, keep everything open.
V is equals to I.
Right. So Ohm's law tells us that because V is equal to IR. And if I want to find out R, I get it as V upon I. Okay. So we have seen on page number 176, to look at your textbook, page number 176. We have a graph of V versus I. This is a graph of V versus I. That means V is plotted on the y-axis and I is plotted on the x-axis. So what does it tell us? When you are having V is increased, I will also keep on increasing. What is V? Which is the potential difference. So the greater the potential difference, we have seen that greater is the current. So if I'm increasing the potential difference, the current also will be higher. Okay, so these two are correlated. And we always find that V upon I, R is going to be a constant. So you will get a graph which is looking something like this. It's going to be a straight line graph up to the origin. Okay, you understand? So it is the slope of the graph. This slope of the graph is going to be R. So R is given by the slope. What does it tell us? If I'm taking small difference of potential difference, V, that means this part is referring to your V. So from here to here. So suppose this is your V2 and this is your V1. So this difference between V2 and V1 is your this axis. Similarly, if I want to find out what is this is referring to your I. So suppose I say this is I2 and this is I1. So the difference of I2 and I1. So here V is equal to V2 minus V1 and I is equal to I2 minus I1. For any difference, R is going to be a constant. Is that okay? So the constant Ohm's law on a particular resistor, V versus I, is always going to be a constant. That is the ratio which is going to be a constant. Is that okay? So we have also seen with reference to the experiment. How did we do the Ohm's law experiment? We kept on increasing the current. Okay. When we are changing the potential difference, when you are changing the potential difference or the voltage, you're finding that I is also increasing. And if you take a ratio of VA versus I, it is going to be R is going to be a constant. Correct? Next, we have also seen what is known as this. What is this? Resistivity. Isn't it? What is resistivity? If you recall, resistance is directly proportional to length, and resistance is inversely proportional to cross-sectional area. This we have already seen. If you look at your notebook, you recall this one? Yes, we have seen. So if we are combining these two equations, first and the second equation, we get it as equal to rho L upon A. What is this? Rho is nothing but the resistivity of the material. Okay, so rho depends upon the type of material that you are using, whether it is silver or gold or whatever it is. It does not depend upon L and A. Okay. Now I want you to write down a table which is giving you difference between R and rho. Are these two the same? Definitely not. So we try to recall and write down what are the points. Difference between R and rho. R. First point. First one will be the definition. So what is resistance? How can we actually define what is resistance? is resistance. You remember what I told you? Suppose there is a tube there and there are stones which are put inside. So it is the resistance or the opposition which is offered by the resistor to the flow of electrons. Take the resistance. First one. First point. It's better you write it down in the form of the table so that you have all the points on the same page. I want resistance. Resistance is the opposition offered of a closeness. I really like to what to do. Shall I switch on this? Up close. I can't scream louder. So is the opposition offered to the flow of electrons by the wire to the flow of electrons. Okay. Now for resistivity, how will you write? What is the definition? Now the same thing I'm going to use. Look at this formula. Okay. I want to find out rho L upon A, which is equal to R. Look at the code. I want to find out what is rho. So what will I do? This will come on this side. So rho is equal to R, A will come here, L will come here, RA upon L. Is that correct? So this will be the formula for resistivity. So that means resistivity is equal to resistance if your area of cross section is 1 meter square and length is 1 meter. Right? Right. Resistivity is equal to resistance if the length is 1 meter. If the length is 1 meter and the area of cross section of the wire is 1 meter square. See this. A is equal to 1 meter square and length is equal to 1 meter. Is that okay? So this gets cancelled out. So you will have only resistance and so resistivity is equal to resistance. When is it? Only when under such conditions. Okay. Next point. So first point was your definition. Second point, can you recall for and write on the formula? How can you find out R? This one. Second point. Second point you write down is for resistivity. Third, what is the unit of R? It's ohm. Ohm. Unit is ohm. What will be the unit here? Ohm meter. Isn't it? How did you get it as ohm meter? R is in ohm. Okay. Area is meter square. Length is meter. So it will get cancelled and you have ohm meter. Fourth one. resistance depends upon length and cross-sectional area.
Length
and cross-sectional area. Resistivity. It depends upon the type of material. Or you can write it is the characteristic property of the material. And if you get the table here, okay, so you are irrespective of whatever length you take, the resistivity will not change, it will remain the same. So it is the characteristic property of the material. So you have got 4 points. Okay. So I think last time we have also done a couple of questions, text questions, etc. Now I'm on page number 181. Page number 181. I just write down V is equal to IR. This is your Ohm's law. And we'll be using this Ohm's law now. Resistance of a system of resistors. You see that topic here? Resistance of a system of resistors. So you have resistors which are shown like this in the circuit diagram. Suppose I have only one resistor with the resistance is equal to 1. And I'm going to connect it to from, let us say this is your ammeter, this is your switch, positive and negative. So when the switch is switched on, the current flows from the positive right up to here, goes through the ammeter which is telling you how much of current is being supplied, and then back again. Okay. So this is your R. If I want to find out R, I also want to know what is V and I. You see that? I can find out because ammeter I've already connected. Okay. How will I find out what is V? I need to have a voltmeter. And the voltmeter is connected in parallel. This is a simple circuit with only one resistor. Okay. Suppose I have got 1, 2, 3. If it is connected end to end, how will that actually look? So the first one that we are going to talk is in series. Okay. This is only with one resistor. Suppose I have 3 resistors. I have got one R1, I have another one R2, and I have another one R3. So I have taken 3 resistors and it is in series. Why did we say it is in series? Because they are all connected end to end. See like this. Okay, one is connected to the other. Now the rest of the series, the circuit will be the same. I have a positive and a negative. Okay, I may have an ammeter here, or I can have it there also, no problem, as long as it is in series. And then of course I'm going to have, let's say, a plug B. Is this and that one the same? Is it the same? What is different? The more resistor, but the rest of the circuit diagram is the same. Whether I put the ammeter here or I put the ammeter here, it is the same because it is only measuring amount of current. Now I want to find out what is the total resistance. Okay, what is the current which is flowing? How will I find out? So when I switch this on, suppose I switch this on, the current will flow from the positive and it goes through all of them. Did you see? It's like a pipeline. So the water is flowing through all of them and it is coming back here. So what is saying here? I know that current I is the same in all the three resistors. But will all of them have the same potential difference? No. What do? I'm going to take 1 voltmeter and I'm going to put it across here. This is going to give me V1. What is the reading here? It can be any reading, 0.2 volt or something like that. Right? So for R1, voltmeter reading is V1. Next, what will I do? I will take this out and then I'll put it across here. Okay, so this will give me V2. So for R2, the potential, the voltmeter reading is V2. Similarly for R3, it is equal to V3. Is that understood by everyone? Okay, so I have 3 separate readings. Let me say the readings are 0.1, 0.2, 0.1, whatever it is. And it could be same, it could be different depending on the resistors what happens. Now I want to find out what is the potential difference across all the 3 of them. So what will I do? See here. So I'll take it out and across all the 3 of them. So across all 3. Did you see this? Did you see the diagram here? Across 1, 2, and 3, and I have V. So what is my V? And because it is in series, that is going to give me the resistors. If they are in series, we get the potential meter, that is the voltmeter reading here. Okay? And it is actually seen that your V, whatever reading that you get, will be the sum of V1 plus V2 plus V3. Is that okay? This you can actually perform an experiment and see. V is equal to V1 plus V2 plus V3. Is that okay till now? Okay. Suppose you are having, let us say this 0.1, 0.2, and let us say this 0.3. How much will that be? It is equal to 0.6. Okay? So this reading also will be 0.6. The one that we have connected like this. So what does it tell us? That the potential meter, the voltmeter, okay, reading is going to be the same as the sum of the individual voltmeter readings. Now what are we going to do? Is we are going to be talking in terms of volt about the volts law. Here V is equal to I1. I want to substitute V. So for V, what will I put? I can put it as IR1 plus IR2 plus IR3. Should I put it as I1, I2 and I3? Why not? Because it is the same current which is flowing. Did you see that? The current is the same which is flowing. So I don't have to put it as I1, I2 and I3. I just put it as I for all of them. Okay? Therefore, this V is equal to I bar. So I R S. Why did I put it as S? Because S is for series. Okay? So here I is constant, I is constant, R1 plus R2 plus R3 is equal to I R S. I and I will get cancelled out. Right? This will get cancelled. So therefore RS is equal to R1 plus R2 plus R3. Is that okay? Did you understand? Okay, very simple. All that we are finding out is what is the resistors if we have got 2 or more resistors which are in series. Clear? Now, look at your textbook. There is one diagram here. Put a tick mark because this diagram gets repeated. Okay? This is one diagram. And the other diagram is also here. This one. Put a tick mark here also. And write it as RS. Okay. What are they showing here? They are showing you how we are actually putting the voltmeter across the 3 resistors. You can't read the way, right? Will you read? Resistance of a system of resistors. Read 181 page.
In preceding sections, we learned about some simple electric current circuits. We have noticed how the current through a conductor depends upon its resistance and it runs across its ends.
Underline this. Conductor depends. Okay, current in a conductor depends upon the resistance and also the potential difference. In
various electrical gadgets, we often use resistance in various combinations. We now therefore intend to see how Ohm's law can be applied to combinations of resistors. There are two methods of joining the resistors together. Figure 11.6 shows an electric circuit in which three resistors having resistance R1, R2, and R3 respectively are joined end to end.
Underline this. End to end. End to end is not like this. Okay, this is one resistor, this is the other resistor, it is joined end to end. That is the difference. For parallel, it will be like this. See? Like steps in a ladder. Like this, one above the other. For resistor, this is the way we are carrying.
Here the resistors are said to be connected in series. Figure 11.7 shows a combination of resistors in which three resistors are connected together between points X and Y. Here the resistors are said to be connected in parallel.
Did you notice how the diagram is? They're connected in parallel. That we see, there's one above the other like this. Okay, so that is in parallel. But for series, it will be one after the other. Here, see here, on this diagram, you will write it as RP so that you don't get confused. Okay. Resistors in series. Isha, can you continue?
Resistance series.
You can read? I thought you have a very bad read, no problem.
What happens to the value of current when a number of resistors are connected in series in a circuit?
What is the answer? What happens to the value of current? See here. Yes. What happens to the current? It is the same current which is passing through the circuit. Nothing happens, there is no change.
What would be the equivalent resistance? Let us try to understand these with the help of the following activities. Join three resistors of different values in series. Connect them with a battery and ammeter and a plug key as shown in figure 11.0. You may use the resistors of value like 1 ohm, 2 ohm, or 3 ohm, etc. and a battery or 6 volts for performing this activity. Plug the key, note the ammeter reading.
Ammeter.
Change the position of ammeter to anywhere it will be the resistors. Note the ammeter reading.
Okay, 1 minute. Now what did they say? If I take this ammeter from here, okay, and if I put it here, will it change? No. If I put the ammeter here, will it change? No. Why? Because it is the same current which is passing through the circuit. Yes.
You find any change in the value of current through other.
What is your answer? No. The current remains the same. Okay, we want to take it down. Write it in your textbook itself. Current remains the same in the circuit. Okay, now Isha.
You will observe,
Yeah.
you will observe that the potential difference V is equal to the sum of potential differences
Wait,
V1.
here. This one.
You will observe that the value of current in the ammeter is the same independent of its position in the electric current circuit.
That's a very important point because we are going to write down that point. Put a tick mark or star or something.
It means that in a series combination of resistors, the current is the same in every part of the circuit, or the same current through each resistor.
Okay, very good. Okay. Now this activity is also a part of your RS. Okay, what is difference here? Only thing is showing you the position of V. That means they have put a potential voltmeter in order to find out the potential difference between R1, R2 and R3. Okay. So for each one of them, just like this, you are taking it out, putting it here, here and here. So you will understand that there is a different reading for the voltmeter in each of the three positions. Continue.
Activity 11.5. In activity 11.4, insert a voltmeter across the ends X and Y of the series combination of three resistors. As shown in figure 11.6, plug the key in the circuit and note the voltmeter reading. It gives the potential difference across the series combination of the resistors.
1 minute. What does a voltmeter do? What is the... Yes, underline that statement. A voltmeter measures the potential difference across the two ends of the resistor. Here, for example, they have given as X, Y, whatever it is, between point this and point that. It can be A, B, X, Y, whatever it is. Did you underline that? So, a voltmeter.
Okay. Let it be V. Now measure the potential difference across the two terminals of the battery across. Compare the two values. Take out the plug key and disconnect the voltmeter. Now insert the voltmeter across the ends X and E of the first resistor as shown in figure 11.8. Plug the key and measure the potential difference across the first resistor. Let it be V. Similarly, measure the potential difference across the two resistors separately. Let these values be V2 and V3 respectively. Deduce a relationship between V1, V2 and V3.
Okay, so what did we find? Suppose we have got the readings for V1, V2 and V3. We find that the sum of all these things is equal to the actual value of the voltmeter across all the three of them. Okay. Okay.
You will observe that the potential difference V is equal to the sum of potential differences V1, V2 and V3. That is, the total potential difference across the combination of resistors in series is equal to the sum of potential difference across the individual resistors.
Put a tick mark in your book. So that is an important point which I have already put it up here.
That is, V equals V1 plus V2 plus V3.
Yeah.
In the electric circuit shown in figure 11.8, let I be the current through the circuit. The current through each resistor is also I. Resistors joined in series by an equivalent single resistor of resistance R, such that the potential difference across V across it and the current I through the circuit remains the same. Applying the Ohm's law to the entire circuit, we have V equals I into R.
In your book, can you quickly sketch this diagram? 2 minutes, quickly you should sketch it. This is what is needed. So this is resistors connected in series. Switch is on.
Finish it.
Is it finished? Okay. Now, write down the important points. Ready? First point. Current business same. First point, current business same with the survey. Second point, you will write the voltmeter reading is all this.
Voltmeter reading.
For R1 it is V1, for R2 it is V2. Okay. Third point you will write. It is seen that point number 4, you write this according to Ohm's law. V is equal to IR. This is point number 5. And 6, and this is point number 5. Okay. Is that okay? Did you understand?
I want to write that IR is equal to IR1 plus I.
Point number 5 onwards, 5 all those 3 steps you will write. At a point number 5, all the 3 steps, and finally you will get the final equation. RS is equal to R1 plus R2 plus R.
That is case 2.
According to Ohm's law. Okay, one very simple sum we can do by looking at this, and once we see the actual numbers, you will also understand another point. Okay, take down this question. 3 Okay, I'm just giving you some values just for us to understand. Are connected find the equivalent resistance.
We have to copy.
Yeah, this is the sum we will do. I've given you the values. Are connected in series, that is important. Find the equivalent resistance. What is the meaning of equivalent resistance? That means once you add up everything, you find out the line.
4.5.
Yeah. So you just write down the formula and you would obviously get the answer. So it is equal to That is okay. Now, what is it that we observe? We find one very important thing. Your equivalent resistance is greater than any of the individual resistance. Did you understand? The final answer that you get is greater than the individual resistors. Which is the highest one here? It is 2. Obviously, it is more than that. So, I want you to underline that point which is given in your textbook. See page number 184. Here, did you see them? See here. See here. Children, see here. Okay. I'm reading it out. We can conclude that when several resistors are joined in series, 184. You shall read that.
Okay. We can conclude that when several resistors are joined in series, the resistance of the combination R S equals the sum of their individual resistance R1, R2, and R3, and is thus greater than any individual resistance.
It is greater than the individual resistance. Underline that point. Underline. Okay. Make a note of it in your notebook. Come on, write down. When several, the last line. When several resistors are connected in series, the resistance of the combination is equal to the sum of individual resistance. And it is greater than any individual resistance. Is that okay? So this thing is actually, you can actually see how to perform this in the laboratory. I don't know whether your school is going to take you, but just to give you an idea, this has got both resistance in series and parallel. So we just look at series first so that you understand.
And also parallel. So I've got a couple of resistors here. These ones are identical, and I've just covered up the value of these resistances. So we can actually work this out in the experiment. Now, the first thing we're going to do is we're going to connect it into a very simple circuit. I've got my cells here. I'm actually going to be using just 2 of them.
Did you see that A? What is that? That's your ammeter. And the other one that it has is your voltmeter. Okay, so as soon as you plug in, you will be able to see the reading of the voltmeter and ammeter.
Because we're going to go up to a maximum, and it says on here, a maximum of 4 volts. So I'm just going to use 2 of these. And we've got an ammeter and a voltmeter. So the first thing I'm going to do is just connect one of these resistors into the circuit, and I'm going to put it just with the ammeter. And this allows me to check that the ammeter is working, that all of the wires are working, and that this resistor is working.
Do you see now? Cell. Okay. There is a resistor to the ammeter, from the ammeter back in. So as soon as you plug it in, obviously there is a number which is coming on the ammeter. What does that tell us? The quantity of current which is flowing in the circuit. Is that okay?
Well, so we can see when I do that, that we've got a value of 0.26 or 27 amps.
Yes.
Okay, so we know that the circuit is working so far. What I'm then going to do is I'm going to connect my voltmeter in parallel to the resistor. And this gives a reading of 2.
You see how the voltmeter is connected? It is connected in parallel. Okay, it's not connected in line with that. It is connected in parallel because we have to find out what is the difference here across the resistor R. Okay, that's the exact line that we are drawing. That is the resistor. Correct?
0.68 volts. Okay, so we've got the current, we've got the potential difference of the voltage, and that means we can now calculate the resistance of this resistor. So if you want to take a record of these readings now,
What is the formula for R? We know we know V, we know I, okay, so we can calculate the resistance. Okay. Now,
I'm then going to take this resistor out, and I'm going to replace it with the other resistor. Now this is the same value, so these readings should be similar. And we can see that this one is fluctuating between 2.4 and 2.5. So it's really your judgment about which value you use. So we've now worked out the resistance of these two individual resistors. We're now going to see what happens when we connect them in series.
so in series, what he has found out for one R1, he has found out for R2. Now we are going to make it in series, and then we are going to do the same thing again.
So to do that, just to make sure that I don't get confused with the wires, if I just take the voltmeter out, what I'm now going to do is just put the two resistors like this. I'm going to connect them up with this wire. And once again, now they're in series, we can see there's a reading of.
You see that these two are in series now? The connection is already done. And now, of course, the value will obviously be different.
The ammeter, and if I put the voltmeter in parallel, this is the reading that we're going to take.
Did you understand the whole circuit diagram? That's basically what.
So what you can now do is you can look at the total resistance of this combination of resistors in series.
So that is your R. So what is RS? RS is equal to R1 plus R2, whatever it is. Okay, so that is sum of all the three of them. Is that okay? Next, we'll do this example 11.7, which is there in your textbook. It's a very nice example because it helps you to understand. You have this example.
11.6 in this.
Yeah, in the textbook. Okay. So they have already given you a circuit diagram many times in the examination. Circuit diagram is given with the numbers and we have to pick up and write it down. So let's see what they have given here. If you look at the diagram, draw a rough diagram. Ready? Just for you to understand. Once you get the idea of how to do it, then it becomes very easy. So you have one resistor. They have given you it is 4 ohm, and there's also a bulb. What is given and what should we find. Along with the circuit diagram, they have also given you some kind of information. Electric lamp whose resistance is 20 ohm. Okay, so that's given here. So we can definitely write down here, this is the electric lamp and it is 20 ohm. This is the resistance. And a conductor of 4 ohm. So this is your conductor of a 4 ohm, which is connected to a 6 volt battery. So your battery here is 6 volt. Ishan, ready? Sketch it out in your notebook, please. Calculate the total resistance. So what should we find? Calculate the total across the lamp and the conductor. Did you understand? This one. Yeah, just a rough diagram. Don't do too much in detail and all, just for us to understand how it is calculated. So we have to understand that this is a resistor. If you look at the sum, read the sum, Ishan.
What's that? The bulb?
This is the bulb. Here was example number.
First,
I'm doing example 11.7.
oh, an electric lamp whose resistance is 20 ohms.
they दिया है ना वहाँ 20 ohm is the resistance. तो एक वाला ये वाला हो गया. Next, what is the?
And a conductor of 4 ohm resistance.
So we have written here 4 ohm. Okay. How will you make out it is a resistor? By looking at the symbol. Ohm, obviously it is going to be resistance. So I've got R1 here, I've got R2, 24. Okay, tomorrow. So you will know what is the total resistance. 24. R is given to us, V is given, so we can find out I. How can you find out I? This formula. I is equal to V upon R. Okay. V is already given here. Once again, it is given there. See, 6 volt is given.
0.25.
Okay, so V is known. R we already know it is 24. I can calculate.
0.25.
Come on, do it stepwise. First step. R1 is equal to 20.
EV. What is EV across?
Potential. Potential difference. PD we can write it.
What is difference across lamp and?
Yeah, this is the question that they have asked. Find the potential difference across the lamp and the conductor. That means across this point and this point. Suppose I call it as X and Y. I have to find out what is the potential difference here. So obviously my voltmeter will come here. And this is what I have to find. Okay. First step, please write down. R1 is equal to 20. R2 is equal to 4. Therefore, RS is equal to R1 plus R2, which is 24. Oh,
RS is equal to
R1 plus R2. R1 plus R2. Okay. Now,
24. 24.
ohms. Okay. First one you have already got. This you have already got it to find total resistance. Next is find current. Use Ohm's law. Come on, right now. Using Ohm's law, I is equal to V upon R. Okay. So I is equal to how much? V is 6 volt. R is 24 ohm. How much is that?
0.25.
1 by 4. 1 by 4 is equal to 0.25. What will be the unit here? Because we are finding out current. See, A, ampere. So you write it as Ishan, write it. I know it is there in the textbook. आप करोगे तो थोड़ा practice हो जाएगा because it's the first time you're doing it. Then it becomes easy. Okay. Then what else are they asking?
Potential.
What is the potential difference across the electric lamp and the conductor? Okay. Once again, we can use this.
You have to 0.25. They are written 8.2.
0.5. A is what? Ampere.
They have to put a dots at the start.
Ampere. Okay. Now we have to find out across both of them. So what are we going to do? Find out this. A is equal to I into R. I know the value of I that they have already given. I know the total value of R. I we have already found out here. We know R. Find out E. How much is it? How much is your V? Here. V. What is your current? Current is equal to 0.25 ampere. Okay, times resistance. I already found out that it is equal to 24. 24 ohm. So how much is that?
6.
Is it 6? Calculate this and tell me.
6.
Do it. Okay. So 6 is already given to us here, so we can confirm it is correct. Okay. In the textbook, what have they done? They have found out for this, they have found out for this, then V1 plus V2, which is equal to 6, either which way. Sometimes they may give you individually, sometimes they may ask you to find out in combination. Do the math there, you get it. 0.25 is what? 1 upon 4. So this is 24 upon 4. So it is going to be 6. Is that okay, clear? Yeah? Okay. So now we have done RS, right? We are going to see now a couple of examples here. See the in-text question. See the in-text question. Here. Draw the schematic diagram of a circuit consisting of a battery of 3 cells, 2 volt each.
Abhi koi gaya.
Draw the schematic.
Now whatever it is given here, this question. You should have in-text question. Okay, anyway, take down. How will you draw it? Sometimes a drawing is given. Read it carefully.
Which question?
First one. In-text. Draw.
Draw a schematic diagram of circuit consisting of a battery of 3 cells of 2 volt each, a 5 volt resistor and 8 volt resistor and a 12 volt resistor and a plug key, all connected in series.
Okay, chalo. Cut them. So what are the 3 things you like to get confident? You comment it here. What are the 3 things that they have given? Have they given you values of the 3 resistors?
Yes.
How much?
5, 8, 12.
Okay, very good. So here only I'm going to modify this diagram so it becomes easy for you. So here we will do a little bit of modification. In series. So 1, 2 and 3. How much is it? 5? Follow, kitna hai values follow?
5, 8, 12.
8 and 12. So these are all R1, R2 and R3. What else is needed?
Plug key.
So we'll put a plug key here. Then
Battery.
how much?
2 cells.
How many cells?
2 cells.
Only 2 cells?
3 cells.
3 cells. So that is 1, 2 and 3. How much is it for each
2
one?
volt each.
So 2 into 3, how much it will become? That becomes 6 volt. What else? No, there's something else about ammeter also, no?
Oh, no.
They're not given
Plug
ammeter?
key also plug.
Okay, fine. If I have to put an ammeter, I can put it here. Okay? So this is your diagram. Come on, quickly copy it down.
वॉशरूम गया हुआ था तो इसलिए जा रहा था इसलिए मैं रुक गया.
So write down the question number also. This is on page number 185. In text question number 1. Many times they'll give you a question like this. Drawing of a circuit diagram. That you can draw anything, 2-3 lines like that. There's no need for you to resist.
So the side I did the last day.
That's all.
Why is this chapter little big or is this chapter little big or
It's going on, no, it is going on. Your understanding that is important. Whether it is big or small, it is not important.
No, it's because one day I'm asking when what you will start next.
Let us finish this, then we'll think about what is going to start next.
Really like this. We are practicing like because it's in my first question. Today I'm not getting a little bit of questions. I'll show you in next class.
No, Acha, one more thing. Whenever they give you, they announce that you are going to have tests here in UP, please take it. If you take it, then it will give you practice. You'll also know the type of questions that are going to be expected. Okay? Now, see the second question. Read the second question. We draw.
Ammeter and voltmeter.
हाँ, तो अभी मैंने ammeter draw किया है. Read the full question. See the second question.
Circuit of question 1, putting in an ammeter and measure the current through the resistors and the voltmeter to measure the potential difference across the 12 ohm resistors.
Okay, now where is the 12 ohm resistor?
RC.
So across that you should put a voltmeter. Anyway, I have drawn the ammeter. Come on, draw the voltmeter across the. We are doing question number 2.
Question number 2.
Okay. Read the question. What will be?
What would be the readings in the ammeter and the voltmeter?
So what is the reading in the ammeter and the voltmeter? How will you do? Now from this diagram, what to find and we are doing now. So what is the reading for R1, R2 and R3?
Will be 25.
So RS is how much? Add up everything.
25.
Correct. Okay. Do I know this? I know V. V is 6 volt. Therefore, can I find I? I can find out I by using Ohm's law. I is equal to P upon R.
6 upon 25.
How much is that?
2.5. 0.
I is equal to
0.2.
same thing like what we did last time, no? 6 divided by 25.
0.24. 0.24.
0.24.
Correct. So here, what will be the unit here for I?
I clear.
Correct.
A.
Ampere. तो आपका आंसर आ गया 0.24 ampere. Okay. What else are they asking? What will be the readings in the ammeter? Ammeter ka we already have found out, that is your current. And what will be the reading in the voltmeter? Where have we put the voltmeter? Voltmeter we have put it here.
Only for one.
Yes. Yes, because it's given in the question. Across the 12 volt. How will you find out there? How will you do this? Yes, I already know. What is I? I is already given as 0.24 ampere. Here R is 12. And I have to find out V. Same thing, V is equal to I.
2.8.
How much did you get? 2. What's the value? Do that. You can't do mentally. Come on. 12 times 0.24.
2.88.
0.24.
It is 2.88. 2.88.
Correct. That's your answer. Come on, write it down. See, Krishvi, 0.24 is the same as 0.24, no? Right? Do. Till now you have followed how it has to be done. So sometimes your questions can be in the form of a diagram and they've asked you to take down the data from the diagram. Okay, now we are going to do resistors in parallel. Now that you have understood series, parallel will be very easy. Shall I wrap it up? Everybody is taking it down. Okay. Now we do about only this part. One part of it will be same. Suppose I have 3 resistors. Now look at the board. I have one with suppose we have got 3 of them. How will that connect? So I have R1, I have R2, and I have R3. And this is the way we are going to connect it in parallel. Okay? That means it's not end to end, but end of each one of them is connected like that. Did you understand? This part of it, of course, you will have an ammeter here. Because this is the positive, this will be positive and negative. And this is it. Have you followed? Okay, it is different from resistors in series. In series, it is like this, end to end. But how did we connect the parallel? Like this, one above the other. Okay. What is the advantage of having a resistors in parallel? Now let me just tell you. In our houses, we have got, let's say, TV, there is a fridge. Okay.
The spans are parallel.
That's what I just explained. Okay. How do we actually connect all of them? Whether we are going to connect it in series or in parallel. Suppose we are having TV, fridge, and oven. All of them, let us say, it is connected in series. Okay. Suppose the fan or fridge is not working. Will my oven work? No, it will not work because in series, it is the same current which is passing. Correct? So all the 3 of them are not going to work. So never are we going to have any of these things or any of the gadgets connected in series, but it is always going to be connected in parallel. So how do we connect? We have got TV, we have got oven, and we have got a fridge. And this is how it is connected. Okay. Now let us say what is happening. Suppose we have the current I is here. It's like a water pipe. Okay. Some part of the current will go here, some will go here, some will go here. Did you understand? Okay. So even if let us say oven is not working, will the TV work? Yes. TV will work because the current is flowing through the TV. Will the fridge work? Yes, because the current is flowing here. So therefore, in a house, Okay, the appliances, fan, TV, or whatever it is, it's always connected in parallel. Did you understand what is the advantage of connecting it in parallel? Okay, first we take down the diagram so that we understand. The diagram is given here on page number 185. Okay, write down. Draw this diagram. Resistors in parallel. Hurry up, hurry up. Complete the diagram. Isha, come on. We do the diagram. Quickly, you don't have to make an elaborate diagram. Sketch is enough for us. Okay. Okay. Right. Now I'm showing you only this part. Only this part. So let us say here. Okay. Now look at the part where I'm drawing the blue. That means this part of it I'm just showing you. So this is the current which is coming. Correct? When it comes here, there are three branches. So let us say this is my R1, this is R2 and R3. I've got current which is flowing in all the three branches. So I'll take it as I1, I2 and I3. Did you understand? It is just like a water pipe. So you have your water pipe going to three different places. And what do we see here? We notice that I is equal to I1 plus I2 plus I3. Correct? How can I make out I here? Because we have our ammeter. So we have the ammeter. This ammeter will give me I. How will I know what is I1, I2 and I3? For each one of them here, I'll put an ammeter. I'll measure this. Are you understanding what I'm doing here? Okay. Again, I'll take it out, I'll put it here. Again, I'll take it out, I'll put it here. So for each of the branches, I will have I1, I2 and I3. Is that okay? Do you understand? Now, what are we going to do? We have to find out what is the potential difference. Now you notice that potential difference across all the three of them is going to be the same. This is your voltmeter. So the value of V is going to be the same across for all of them. Correct? Now once again we have to use Ohm's law. Did you see that? In series, what was that same? It was the current. But in parallel, what is the same? It is the potential difference, which is the same across all the three resistors. Okay. Now, I'm on page number 185. See that last page number 185. Resistors in parallel. Okay. Now let us consider the arrangement of three resistors which are joined in parallel with a combination of cells or a battery. Okay. Activity 11.6.
Activity 11.6. Make a parallel combination XY of three resistors having resistance R1, R2 and R3 respectively with a battery, a plug key, and an ammeter, as shown in figure 11.10. Also connect a voltmeter in parallel with a combination of resistors. Plug the key and note the ammeter reading. Let the current be I. Also take the voltmeter reading. It gives the potential difference V across the combination. The potential
Underline that in your notebook. The voltmeter will give you the potential difference across all the three of the resistors. Underline that.
The potential difference across each resistor is also V. This can be checked by connecting the voltmeter across each individual resistor.
Okay, go on to the next page. Which page?
Take out the plug from the key, remove the ammeter and voltmeter from the circuit. Observe the ammeter increase when the resistor R, as shown in figure 11.11, through the ammeter. Read I1. Similarly, measure the currents through R2 and R3. Let these be I2 and I3 respectively. What is the relationship between I1, I2, and I3?
Okay, now what did we do? Okay, it is observed. Can you read or shall I ask you to read?
It is observed. It is observed that the total current I is equal to the sum of the separate currents to each branch of the combination. Let R3 be the equivalent.
Why did we write a P there? RP, why did we put P there? What is RP? Now what are we doing? These are resistors in parallel, P and R. So that is why we are writing it as RP. If it is in series, I'm going to write it as RS. Okay, so that is R. Okay, read.
Let RP be the equivalent resistance of the parallel combination. By applying Ohm's law to the parallel combination of resistors, we have I is equals to V upon RP.
Okay, hold on. I is equal to what? R is equal to P upon I, or we can also use I is equal to V upon R. Now, which one are we using now?
I is equals to V upon RP.
Did you understand? So we have I, we have V. V is going to be constant for here. See, V is a constant here. Correct? I know the value of I. So that is equal to V upon R. And now because we are finding out RP. So for I1 also it will be the same, which is going to be V upon R1, V upon R2, and V upon R3. V is common for each one of them. So from here what do we get? Therefore we get it as 1 upon RP is equal to 1 upon R1. Did you understand, children? Is it, can you say it is the sum of R1, R2? No. No. It is the reciprocal of the. You understand what is reciprocal? It is 1 upon 5, 1 upon something. So the reciprocal of the equivalent resistance is equal to the reciprocal of the individual resistance. Is that okay? Did you understand that part? Okay. Now just let us see the video so that you understand how they connected, and then I can just give you a few points to write. Okay, now watch. Till now we have seen series. Let's see how these would connect.
The last thing we're going to be doing is looking at resistors in parallel. So again, once again, I'm going to take the voltmeter out. I'm just going to disconnect the resistors. And now I'm going to connect them up in parallel. So,
did you see how it is connected in parallel? These two connected in parallel. Okay.
It's just worth taking care, keeping an eye of where all of the wires go. So we can see now we have a higher current because we've got these in parallel. And I'm just going to put this across the terminals here. Okay, so now we've got 2.46 volts, and that's going to be across both of these, and we've got 47 or 48. So we've now got readings for the.
So what happened? What happened to the current? Did you notice what he said? Very good. It has increased. Okay, so when you're connecting the resistors in parallel, the current has, okay, so it is obviously
And voltage, and we can now look at the total combined resistance of this combination of resistors in parallel.
Did we understand? Okay, so actually you will be performing experiments in the class by taking all these things. Okay, now let's just write down this, children. Only this one, come on, write down. It is seen that from here, right? It is seen that I is equal to I1 plus I2 plus I3, and B is a constant across all the three resistors. Across the three resistors. Now, here you will write using Ohm's law. Write down this. Okay. We already have that I is equal to V upon I R. And we are substituting here. Okay, 5 minutes more, 7 minutes. It's time?
9 minutes.
Okay.
Even you want to.
I'm okay, thank you. Okay. So, shall we do one simple sum? We actually using those numbers so that we understand what happens to I, what happens to V, and so on and so forth. Okay. There's one example. Just write down. Last one, last point, all of you write down. Therefore, the reciprocal, use the word reciprocal, very important, reciprocal of the equivalent resistance of a group
Resistance.
here. Thus, we may conclude that one.
Reciprocal of equivalent resistance of a group of resistors joined parallel resistors.
So that is very important. Sum of the reciprocal of, underline it. Now, many children forget to write the word reciprocal and the whole thing will go wrong.
Yeah.
Are you following what is happening here? Okay, easy to understand? This is over in your school hour?
Yours even started.
Okay. What about yours?
Light is on the
First three.
reflection is
Even in our school, almost end of the light, but they are not complete.
Okay.
Electricity and magnetism.
So we are trying to balance it. Once we finish this, again we'll have to go back to the chemistry lesson. So alternate one chemistry, one physics, that is okay. Okay. Have you all written that sentence down? That's very important. Okay, now let's do this example 11.8. It's an example sum, but it is very nice because we'll understand how to plug in the numbers. in the circuit diagram, suppose the resistors R1, R2 and R3. Write down the values. 5, 10 and 30. Which have been connected to a battery. Okay. Now to find current. Total current. Let's do the first thing that they have given. Okay. Now we know that R1, R2 and R3 is there. We can find out what is the current in each resistor, total current and total circuit resistance. Okay. See the first question. Find out the current in each resistor. So current we already know. Okay, I is equal to V upon R. Do we know V? V is already given to us. So for I1, it is 12 upon R is 5. Similarly for I2, okay, V is 12. In each of the cases, R will keep on changing. And for I3, so you will know the values of current in each of them. Come on, do it. Do this step. Done? All the three? Good.
The first is 2.4.
Correct, okay.
I1 is 2.4, I2 is 1.2, I3 is 0.4, and the total is 4.
How did you get the total? Add up everything.
The total is
2.4, 1.2 and 0.4.
Okay. So you got 2.4 and
1.2
yes,
and 0.4.
correct. So you have found out the current in each resistor. Now how will you find out the total current?
Add all of them.
Yes. Write a formula. I is equal to, and make sure that you are writing the current unit.
and the total resistance is 40%.
How much did you get here? How much is that?
That is 4.
484.
4.
Okay, this is okay.
4.2.
Total circuit
Getting
resistance.
3.8.
How we get 4 and 4, 8, 8 and 0.2.
Yeah, sorry, 4.
Now we will do the third part. Calculate the total circuit
45.
resistance.
45.
3 ohm meter. Sorry, 3 ohm.
Total resistance 45.
R you have to find out using this. R is equal to V upon I.
We have now
I we know. V is already given here. 12.12 volts is given.
3. Total circuit is R. Circuit is 3.
3 R is 3.
3.
How did you do that?
12 upon 4.
Exactly. what happens if at all now that they have given you that all the three of them are connected in parallel? So 1 upon RP
I did that.
this way. Because there are three which are connected in parallel. Okay, so you are expected to do this. So now you have to find out the LCM and then do it. Here also you get the same LCM. Yeah.
10 upon 20.
You know to take to do the LCM method. To do that
0.33. It is the answer.
RP 1 upon RP P inverted though.
I was telling the answer on that. 1 upon RP.
Okay, do that.
That the answer is clear.
Did you do that LCM? So you have got 5, 10 and 30. So it is 5, 1s are, 2s are, that is 6 are. Again you take 2. 5 to 10 and that is 30. Did you do this working? So you should be getting the same answer either which way. Okay. Check.
1 upon 3, so it will be reciprocal.
So in this experiment, we're going to be measuring the resistance of.
1 up, like R is 3.
Because 1 upon
It will be reciprocal.
Yeah,
1
which
upon
is
3. But I can't be so directly, like we solve this, but that 12 upon 4.
चलो हाइब्रिड जो बोलता है नीचे खाना है क्या?
तुम लोग बताओ तो पहले लाना क्या है? सुबह से लेना है।
मेरी आ गई है क्या?
थोड़े ICSE मेरी क्लास तो हम
जाना जा।
चल तो जाने दिया था ना?
हाँ यार तू जा। कल ऋषि ने दिया
लाना क्या है और कहाँ से लाना है?
देख तू यहाँ पे जाएगा ना आगे मेडिकल है और इस तरफ जाएगा तो टपली तू
नहीं
यहाँ पे जा तो मेडिकल जा
तू मेडिकल जा
क्योंकि देखो वहाँ पे ज्यादा ऑप्शन
तू
है
जैसे जाता है ना बाशी प्लाजा की साइड से
हाँ उधर ही मेडिकल
समझ गए वो पोलो
हाँ समझा था
वो जो भी मेडिकल है
अपोलो है रे।